We'll talk a bit about conformance testing with looking at two different test suites and what we can learn from those. And just for background, the reason we're here is that the two of us implemented the TUF Conformance test suite this summer over a couple of months. And we figured it makes sense to talk about it somewhere. And it turns out that this audience should be pretty good because of two reasons. One is that because Sigstore Conformance already existed, we stole everything we could from there. So the test suites are similar. And the second one is that the difference is that we end up having are actually the interesting bits that might be useful to others as well. Go ahead.
So a brief introduction to the test suites, the TUF and Sigstore Conformance test suites. Then we'll look a little bit under the hood of the test suites, how they work, how they're put together. Then we'll look at some findings, some actual findings that have come out of them. And then finally we'll discuss future work. Before we introduce the test suites, we'll just define a bit what we mean by conformance. So when we talk about conformance testing and conformance test suites, what do we mean by conformance? And a good way to look at it is across a spectrum where we on one end have conformance testing against the actual specification. With regards to both TUF and Sigstore, they both have a specification that details the behavior of clients and repositories for that matter. And when we talk about the conformance testing against the specification, we extract what's written in these in the specifications and define tests against those parts. So moving a little bit across the spectrum of conformance testing, we have testing of best practices, and this is an area where we want to check and test behavior of clients in areas that are not clearly or if at all defined in the specifications. And we'll get into that a little bit more, what we mean by that later. But for now, it's just enough to be aware that we are talking about testing of behavior that is not precisely and clearly defined in the specification. And some examples of that is key types. Which key types should clients support, and when should clients throw an error, and how should they do that? How should they do so? Finally, going even further away from the black and white testing of specification, conformance testing, we also extract some heuristics from the behavior of Sigstore's public good instance and have implemented those heuristics into some tests in the conformance test suites. So the two conformance tests, they are both public and are hosted in GitHub repositories. So the Sigstore conformance test is the oldest of the two. It was released in 2022 and has 50 tests approximately, and is widely adopted across the Sigstore clients. The TUF Conformance test suite, the user did some groundwork, I believe it was last year, and then the work on getting releasing took shape in June of this year, with the first release in August. It has around 100 tests, a little bit more, and decent coverage of the specification. Some clients have adopted it: Python TUF, Ruby, Sigstore Ruby, and Sigstore JS, right?
There was a TUF test.
TUF JS. ongoing work is being done to adopt this into Java, Go and Rust. So what are they, how do clients consume them and use them? Essentially they are GitHub workflows, or they are meant to be used as GitHub workflows, and using it looks like this. This is Samuel's work from this adoption into Sigstore Ruby, and so fairly easy. You invoke the you see here you invoke test suite here, and you can pass some parameters. I don't think it doesn't look like Sigstore Ruby does that, but there is this entry point here, which we'll talk a little bit about in a minute. But fairly easy and simple to adopt. So this entry point that I highlighted is a CLI tool that we ask, or that the test suites ask clients to implement, and so Jussi will get into that in a little bit. But essentially, when we have the test suite on the left here, and we have a TUF Sigstore client on the right that we want to test, we don't invoke that client directly. We ask it to implement a CLI that the test suite invokes, and then the client is responsible for correctly implementing kind of a middle tool in the middle. But we'll get into that in a few slides.
Right. This just lists some basic reasons why we wanted to do this instead of putting the sort of similar resources to improving testing in general in the clients. Well, the two first ones are kind of obvious in general. That's why I want to test the stuff. But the reason why we're not doing it in the clients themselves is that there is a significant number of them in both of these ecosystems. There is like half a dozen clients. It's a lot of work to improve testing in 6 different projects. The test surface is much larger than it originally seems to be, especially when you start looking at the failure cases, what are the possible failures. There's a lot of them, and as well, the edge cases are difficult to identify. So then if we have 6 different projects trying to identify the tricky bits, it's just harder. And of course, if we have conformance test suites, like I think this came up in the Ruby talk, it just makes it a lot easier to start implementing new things if you really have to. All right, if we look at some of the actual implementation details, and this is, now we have to start looking at the specific test suites. So this one's Sigstore. On the left, there's the actual test suite with separate tests. And then in the middle, you can see the actual Sigstore client code base with the CLI that was mentioned. From the test suite's perspective, everything after the CLI is a black box. We don't know what happens there. The dotted line on the left is kind of the measurable surface. We can push some inputs to the CLI, and we can look at the return values or products that it produces. But other than that, we have no visibility. So the CLI inputs might include things like OIDC token for the signing, and a signature bundle in the verification case. And output in the signing case would be the signature bundle, and in the verification case, well, the only output we have is whether this verification succeeded or not. And the kind of noteworthy part is in the right-hand side, so the clients practically use the public good instance, or in some cases the staging instance, so connect to full geo and so on. It's just that the test suite doesn't see this. And the reason for ending up with this architecture, now I wasn't involved with this test suite at this point when the decision was made, but I can make some very good guesses. The lack of measurability is a bit of an issue, but the design has some really nice features. So first of all, it's quite easy to implement. A typical test in Sigstore Conformance is basically just assets. You have a Sigstore bundle and whether it should verify success or false. It's easy to at least get started. The test code itself is often just a line or two of boilerplate. The major advantage is that it actually ensures real-world compatibility with not just the public good instance, but also staging. So you get early warning if staging maintainers change something and conformance starts failing. That's really useful info, even if it's not strictly speaking conformance to anything. Right, so if we look at the same thing for TUF Conformance, it starts really similar. Test suite calls a simple CLI that we expect to be implemented in the client code base. And then the client library then connects to infrastructure to get some data to do what it needs to do. But the difference here is that the infrastructure is actually controlled by the test suite. And the test suite completely controls the environment that the client sees. This is essentially where every test defines a simulated TUF repository. So what we have then is that the measurable surface includes the same things that Sigstore client did, or the implementation did, plus the HTTP requests to the simulated repository. And then this is not part of the picture, but we're also expecting the CLI to expose the metadata cache content, so basically the client's view of the current valid repository, which is not part of any spec, but we're making that requirement so that we would have more visibility into what the client is doing. And it seems that this is not a problem for clients, so that's why we did it. So why this architecture and not just copying the Sigstore one is basically good. Two reasons for that. First one is that there is no public good instance for TUF, so we're kind of forced into doing something like this. We can't rely on a specific repository to be the kind of source of truth on how TUF should be implemented. But the other good reason is that simulation allows easy testing of many failure cases, and this is really beneficial when we start to consider cases like malicious infrastructure, when the repository actively tries to mislead the client. That's kind of hard to test with a production repository. Yeah, summing up the sort of different approaches here. Compatibility with public good instance is really useful, like absolutely not downplaying it, especially when combined with the support for staging environment. That's just super useful for the Sigstore ecosystem. And TUF Conformance just does not get these advantages at the moment. On the other hand, TUF Conformance has arguably achieved significantly better coverage in a shorter time. So this is just only possible because we control the environment there. And I'm pretty confident in saying that the TUF Conformance test results or I'm more confident about the test results. Are we measuring the right things because the measurable surface is bigger? So if we're expecting a verification failure there, we've got good reason to believe that we know why it failed. So it's not just failing for some unrelated reason. Right, I guess your turn.
Yeah, thank you. Yeah, so let's look at some of the findings that have come out of the work on these conformance test suites. I think there are two types of findings we have come across. One is we have learned something about the ecosystem, and the second are actual issues in the clients that either need to be documented or fixed in some way. So we have had a number of cases where we found non-compliance against specifications. So literally where the specification said one thing, but the clients did another. Then we found a bunch of cases where the specification, not a bunch of cases, a few, where the specification was not entirely clear and the clients disagreed on what was the correct way to, or how clients could or should behave in those cases, where they were not told exactly what to do. Then we have found some actual security vulnerabilities. We'll exemplify one in, I think, the next slide. And we have found that clients in general implement very different things based. I wouldn't say they implement very different things. They implement the things that they need for the exact use case. And there are some Sigstore clients that maintain their own TUF clients, for example, and then they implement what they need, which makes sense. And then from another point, we have found some clients that offer a full feature-rich client, but have specification disagreements with other clients. Then we have interestingly found some code level issues in clients. I wouldn't say we test a lot for that, or that the test suites test for that, but some of the test cases were structured in a way where they identified some code level issues in some clients. Right, so one of the vulnerabilities that came up was in GoTUF. So TUF, you all probably already know that, but TUF has this delegation feature where you can delegate a target to another, so that, for example, here if a user wants to fetch target A, it will be delegated to target B and then to target C. And the test suite then found a case in GoTUF where that would not happen, even though the repository had instructed it as such. So even though this was the metadata, the client would end up with target E, which could, for example, have a security vulnerability that the owner wanted to avoid with this delegation. And yes, the impact covered. So this was quite easy to test for in the case of the TUF conformance testing. I think a big part, or a big part, was really that the test suite controls the test environment entirely, and yeah, so I think it was an issue that was very easy to detect in a normal unit test suite. So yeah, a slide about what the clients implement, what they need.
Right. We already touched this a bit. but it is true that client projects have different focus areas. For example, several TUF clients only implement parts of the spec, and for some this might be like an actual problem, but in other cases, like the client implemented inside Sigstore Java, it was meant only for Sigstore Java, and they could trust that specific features just aren't needed. So they weren't implemented because it was just for their use case. That makes total sense to me, and it's still useful to know and find out, but it's not something where we can really start saying that that's not cool. In Sigstore's case, I think it's been mostly cases where clients just implement different features at a different time because some things are important in some clients and maybe less important in others. There are cases where clients do implement the specification, but some parts may just be not tested quite as well because of the focus they have on something. Just make sure that they're testing this area a lot more than others. Sometimes this focus is an oversight that should be fixed, and obviously conformance testing helps here because we find out the problems and then they can fix it. But yeah, clients focusing on specific areas is not necessarily a bug or something that we can or want to fix. But we can still get value from conformance or testing all of the clients and find out the differences and publicize that difference so that, for example, folks choosing the clients that they want to use in some other project or as dependencies, they can make an informed choice. So this is another finding. 100% compliance is not much in some cases. And don't get me wrong, like spec compliance is great, but there is so much more. And you know, specs, test suits, they're just both tools to get to where we want to go. So compatibility and security. And I think this is just a fact of life when we live in a kind of a smaller community like this. We can't expect, you know, W3C level specs. There are always going to be missing things and so on, and we just have to either fill in the blanks in a test suit or, you know, file box in the specs, whatever makes sense. So if we look at what this might mean, like with these findings, what it would mean for these two projects. For TUF, the compatibility historically has been the Achilles heel for TUF. Like I don't know of any actual compromises of, you know, TUF clients doing something because of, you know, security compromise in TUF, but I do know of several cases of clients just breaking because of repository changes, and I've made that happen myself too. And conformance testing obviously helps, but testing actual compatibility would be even better if we can do both. Testing against real TUF repositories or static snapshots of them is not completely trivial, but I think it's completely doable and fairly well automatable even. And then I mentioned exposing the conformance results, and I think that's something we should consider for both ecosystems. Like it makes sense to make it visible that these clients implement these features or pass these tests. It's just would be nice. Neither test suite currently kind of requires the tester to call home and report results. So currently, if you want to see results, you have to go into each of the client projects and try to find the latest test run and figure it out. But you know, we could probably make it more visible what the results are. especially for TUF, having a client feature matrix or support matrix would be a big thing, I think. So for Sigstore, yeah, if we could simulate more of the infrastructure, I think that would be a win. The test coverage increase that I'm talking about here means that we could, test how the client reacts to a malicious or misconfigured Fulcio, for example, or Recore. But it also means that we could test something like key types. Like if we add a post-quantum key in Recore or something, this would be a way to find out without actually adding it in production. Now, this is a bit hand-wavy, and I haven't looked into it closely, but I know at least Sigstore.js has some Fulcio and Recore mocks, so I'm just saying maybe we could use those here, or at least take some ideas. And then the same thing, just exposing the results would be great. Like if we could see which Sigstore clients do what and how well they're doing it, that would be nice without trying to find the results in their GitHub actions. And finally, like for both test suits, it would be cool to get more testing happening in the conformance test suite, because it then happens in all of the clients and not just one. I don't know how to get that to happen, because it's usually a little more work to do it in the conformance test suite, and you get the results slightly later than you would in your own test suite. But I would love to see it happen. If someone has ideas, I would love to